So in the last videos, I think you know very well, we have completed, sir, up to uh, single linked list we completed, double linked list also I think we have completed, sir, right? In the double linked list, so almost we have finished 19 operations. Okay, almost 19 functions we implemented in our double linked list. Now we have to see the circular linked list, sir. So we will see how we can able to implement this circular linked list. In the circular, again, we have different tools are there, like circular single linked list is there, circular double linked list is there. So we will see that a circular single linked list and a circular double linked list in our videos. Okay, one second. Sir, one second, sir. Please wait. Yeah. So let's go for circular linked list. Sir, in this circular linked list, so just we are going to cover only the few basic things, sir. Okay, in the circular linked list, we are not going to cover every operation. We are going to see mainly so insertions and then deletions. Only that part we are going to concentrate on circular double linked list. Okay. Sir, let us see. We are going to talk about circular. First, we will see circular single linked list. Okay. Sir, what is mean by circular single linked list? The linked list is arranged in the form of circular fashion. That is called as what? Circular single linked list. If you want, let me take one simple example so that you can able to understand well. Sir, observe carefully how I am going to represent. Sir, I have a single linked list is there in this state. So this is my single linked list. So here you can see the first node is attached to the second node, and this second node is attached to the third node. But generally, this field is pointing to null, right? Now, what I am going to do is this one I am going to attach to the beginning. Okay, last node, first node, I mean, last node, next field is pointing to the first node. This kind of structure is called as what? Circular single linked list. And if you maintain two pointers, it will become circular double linked list. Anyway, I will explain how we can able to work with this. And sir, here we need to remember one special point. Generally, the first node is always called as which node, sir? Head node, that we know. And the last node is always called as which node, sir? Tail node. This is also we know. But I am not going to use a head node and a tail node. I will use only one reference, which is nothing but what? A tail. Okay. Sir, then how you can identify head node? Because the next node to the tail is nothing but a head node. The next node to the tail node is nothing but a head node. Like that we are going to refer. Sir, anyway, I will go to implementation of these programs. Then only you can able to understand the concept. Let us take a test.py program. Here you can see. First, I am going to take a class circular single linked list. Like this I am taking. So compulsory node class is required, right, to represent the data and then next pointer. Here I'm going to define a constructor for node class. So in this constructor, we are going to pass the data. At the same time, we are going to pass a next field. If we are not giving any next field, then it is always pointing to the none. Okay. Make sure if you are not providing any next field, it is always pointing to the none. Like this we have. Next, and after that, sir, here I'm going to take self dot data will become the data what we have. Okay, self dot data will become the data what we have. And sir, self dot next will become, it is always pointing to the none. Self dot next, it is always pointing to the none. Like this we have. Sir, 1 second, please wait. One emergency call, please wait, sir. Yeah, sorry for the delay, sir. There was some emergency meeting. That's why from our management side. That is the reason. Okay, right. Sir, am I audible? Please confirm. Am I audible? Please confirm.
Yes, sir.
Right. So here I defined one simple constructor for this class node. This node class, what it is doing? Sir, it is defining a constructor which is going to take two fields. One is a data field, another one is nothing but next field. So if we are providing the data, that data will be assigned to this data field. And if you are not giving any next field, that will be given to this next, like this we have. So then after this, so node class concept is completed. Now what we have to define? You need to define constructor for circular single linked list, sir. Okay, we have to define constructor for circular single linked list, which is going to take only self. And I told right, in the circular linked list, I'm going to take only 2 pointers. What is the first pointer? So self dot, your tail will become none. This is nothing but what? And self dot count will become 0. Like this, we have 2 pointers are there. So first one is nothing but a tail and the second one is nothing but a count. Like this, we are going to assign two variables. So tail is always representing the last pointer. Count is always representing the number of nodes present in the node. Like this, I mean the number of nodes present in the list. Like this we have. Now I'm going to write one more function called size. This size function is going to return which values are self dot count. How many elements are there? It is going to return. This is nothing but size at. Okay. Sir, now what is our next option? We have to perform display operation. I'm going to define a function called print list, which is going to take self and it has to print all the elements present in the list. How it is going to take? We know very well. If self dot tail is a double equal to none, then what is the meaning? We don't have any elements. I'm going to print list is empty and simply we are going to return the control. Otherwise, what will happen? We are going to take a current node which is always pointing at a self dot tail. Okay, like this we have. Now please listen carefully. Here there is one small change is there. So while your current node dot next is not equal to so self dot tail, until it is not equal to self dot tail, simply we are going to print current node dot data field and then so end is equal to I'm giving just space, that is sufficient. Then what about your current node? Current node will become your current node dot next. Like that we are going to take. First, let me consider one simple example so that you can able to understand well. Consider I have a circular single linked list is there with some 3 elements. Okay. So this next field is pointing to here and this next field is pointing here. This next field is pointing here and this last field is always pointing at the beginning. Here we have 10 is there and here we have 20 is there and here we have 30 is there and here we have 40 is there and this first node there is no reference and we have last node reference is there, right? What is this reference, sir? No, it is not head, so it is nothing but which node? It is nothing but a tail node. Like this we have. Sir, my tail node is always pointing at last location. My tail node is always pointing at last location. Now see how this print list function is going to work. Already we defined this print list, right? Let us see how this print list is going to work. Initially, we are checking whether tail node is equal to null. If tail node is equal to null, then what is the meaning? We don't have any elements in the list. We don't have any elements in the list. Sir, otherwise, current node will become self dot tail. Sir, this is the self. So self dot tail or self dot tail dot next. I think better we can take self dot tail dot next. So that what will happen? So which node will become current node, sir? Tail dot next. That is 10th node will become current node. Now check, is current node next that is 20 is not equal to tail. Yes. Then print current data, which is nothing but a 10. Then current node will become current node tends to next. Now this will become your current node, right? Yes. Sir, is current node next is not equal to tail? Yes, it is not equal to tail. Print the current node data, which is nothing but a 20, and move current node to here. Now is current node next field, uh, uh, one second. Yeah, is current node next field is not equal to self dot tail. Better current node next field, instead of that I will take current node next current node field. Sir, is this current node is equal to self dot tail? No. Then try to print the data. Then your current node will become this one. Sir, is your current node is a tail, is not equal to self dot tail? No, it is equal to tail. It will come out from the loop. Sir, one number is missing, right? So where current node is pointing at 40. After coming out from this while loop, you can able to print so current node dot data. So that what will happen, the last pointer it is going to print, sir. Like this we can able to print the elements present in the list. Sir, I request everyone to please confirm, is this display operation related to this single circular single linked list? Is it clear for you people, friends? Please confirm everyone.
Yes, sir.
I request everyone to
Yes,
please
sir.
confirm, is it clear?
Yes, sir. It is clear.
Now, sir, what is the next step? Of course we can't execute because we don't have any nodes, right? As of now we will see insertion at the beginning, sir. So insert at first, I want to insert the object at the first location. Let us see how we can able to perform insert operation at the very beginning, sir. I want to insert the object at first location. Let us see how we can able to do that, sir. It is a very simple code here. Okay, it is a very simple code here. Observe carefully. I am taking the function like insert at first, insert at first, where we are taking self comma data. Sir, now how to write code for this? We are creating a new node with self dot node of I am passing the data field and I am passing the next field as a none. Okay, so self dot, okay, so self dot count will become self dot count plus 1 because we have inserted one node, right? Once if you insert a node, what will happen? Immediately that count is going to be incremented by 1 unit. And if self dot tail is equal to none, if self dot tail is equal to none, that means if we don't have any elements, so then what will happen? The node which you have created will become tail node, will become tail node. And that new node is there, right? Its next field will become new node only and return the control. Sir, when this particular situation is going to be happened, consider I don't have any elements in the linked list. Now what will happen? We are creating a new node, sir. This will become a new, okay, I'm creating a new node. This will become a new node like this. Sir, what about the data here? My data is nothing but consider it is a 30. So next field is what, sir? None. What is the name of this node? Can I say, is it new node or not? Yes, this will become your new node. Then self dot count. Initially 0 elements are there, 0 nodes are there. Now your node will become 1. Now cross check, is self dot tail is equal to none? Yes, because we don't have any self pointer, right? So then it will become none. Then self dot tail is equal to new node. Sir, this node will become tail node, sir. Right. Then new node tends to next will become new node. Have you observed? This new node next pointer, I am going to assign with the same node. Okay. So with the same node. Sir, what is the advantage of this? Better I will write this tail node like this. Okay. Sir, what is the advantage of this? Sir, it is a circular linked list or not? Yes. Like this we have, sir. Consider I want to insert one more node. I'm going to insert here. So I'm going to insert here. So consider this node will become having the data called 20, and the next field is pointing to none, and this name will become what? New node. Sir, which operation we are doing? We are performing insert at first. So automatically this node 30 next field is going to point to the 20 at the same time. So 20 next field will become 30. Like that we have to change the assignments. But here self dot tail is not equal to none, right? That's why what will happen? It will come to the next phase. In the next phase, what I am going to do is new node dot next will become, okay, new node dot next will become, so self dot, okay, self dot uh self dot tail dot, okay, self dot tail dot next I'm taking. Sir, 1 second. Right. Sir, here you can able to see what is happening. New node dot next. Sir, where is the new node? This one, right? Its next field will become self dot tail next field. Okay. So this is the new node. 1 second. I think the mistake I have done. Self dot tail. I mean, this one is the tail. Its next field is what? 30. That will become new node next. That means this link is going to break, and 20 next field will become 30. Like this we have an assignment. Next what we have to do? Sir, self dot tail, we have to take a tail node. Okay, we have to take a tail node. So self dot tail is there, so its next node will become new node, and then at last we have to return. So self dot tail, self dot tail means what? This one. So its next node will become new node. Sir, that's all right. This is nothing but what we have. Okay. Sir, anyway, tail node is always pointing at the ending, right? That's why there is no need to change any tail pointer. Like this, we can able to insert. Can you please confirm, is this insert at the first operation? Is it clear for you people, friends? Please confirm.
Yes, sir. Clear.
Right. Sir, please repeat. Sir, nothing is there here. You need to see the parallelly. I told, right? You have to take a paper and pen, and parallelly you have to practice. Then only it can be understandable by everyone. Okay. Now see one more example I am taking. Okay. Right. Sir, have a look once. Assume I want to create one more node. Sir, where it will be created? Here on. I am giving name of this node as a 10. So this node will become which node? New node. And this node will become what? A tail node, right? Sir, what is happening? Is self dot tail is equal to none? No, because the tail is pointing to some node. Then what we are doing? Your newly created node is there, right? Its next field will become which node? So its next field will become self dot tail dot next. This is the tail. Its next field is what? 20. So that will become which next? New node tends to next. Then self dot tail dot next. Tail next node will become new node. Like this we are attaching. Sir, we are not required to change any tail pointer. Why, sir? Because that is representing the last element. So please confirm, is it clear for everyone? Coming to the next one. Sir, we have to see insert at last. So I want to take a function like insert at last I am taking. Okay, insert at last. Sir, here we are going to take self comma data I am taking. Sir, here what is the first step? New node is equal to self dot node I am taking, where we are going to print so data and then next. Sir, now what we have to do? So here, once if you have created a new node, immediately you have to increment the count by 1 unit because a new node got created, right? So next, here we are going to check is your tail is empty or not. Self dot tail is equal to none. That means if your tail is empty, then self dot your tail node will become newly created. Self dot tail will become your newly created node. So then what we are going to do? Your new node is there, right? Its next field will become so new node, and then return the control. It is same like beginning, sir. Suppose if this condition is not satisfied, that means if the tail node is already existed, then your new node next field will become so self dot tail dot next. Okay, then self dot tail dot next will become new node. So after this self dot tail will become new node. Like this, one more instruction is going to be added. Sir, if you want, I will show you the diagrammatic representation. Have a look once. This is nothing but my total pointers what I have. Here I need to add the node at the ending, sir. Let us see what will happen. So I'm going to create a new node in red color. Please listen carefully. So here your new node is going to be created, and assume the data is nothing but 40. So next field is as of now empty. Your new node next field will become, this is the new node. Its next field will become self dot tail dot next. What is the tail dot next? 10, right? Now it is also pointing to this one. Now tail dot next will become new node. This will become new node. Then tail will become new node. Now onwards, this is not your new node. This is not your tail node. So now this tail node is there, right? This reference is going to move here, and automatically this link is going to be deleted. Have you observed? Is the node got added at the ending or not? Yes. This is the way, sir, how to insert the node at the beginning and the ending. Sir, can you please confirm, is these operations are clear for you people up to this?
Yes, sir. Clear.
Yes,
Right.
sir.
So don't worry about this execution part. We will discuss this execution part in the tomorrow's session. Still continuation is there. Like we have to perform delete operations. After that, I will execute the code and I will explain. Okay. So I will update the running notes after half an hour because I have a immediate batch is there. We will meet for the continuation in the tomorrow's class, sir. Okay. Right.
Okay, sir.
Thank you.
Thank you, sir.